Welcome to this geography class. Today we're going to talk about the atmosphere layers. And to do that, we're going to use this diagram to scale that it has the altitude parameter and also the temperature parameter, because this one is very important to understand how layers work. So we are going to start with the first layer, the air that contains all of the clouds and the air we breathe. Most of this, this is the densest layer and the lowest layer that we are in which we are living, and that's the name of the troposphere. The name of that layer is the troposphere, that is between 0 kilometers of altitude and 10 kilometers. So we have it right here. It's only like 2 centimeters in our diagram, so it kind of doesn't look like much, right? So what is interesting to know about the troposphere? Tropos means change. And that name is because everything in the troposphere is changing. Weather is there, most of the weather, the weather conditions are there. Most of the clouds that we see, some of the clouds it could be even higher, but most of them are in the troposphere. And also we have the weathering and erosion happening there, so it's a really changing layer, right? So we call the troposphere. Let's analyze what is happening with the temperature. Let's analyze. But before getting to that part, let me show you something to understand how small is this layer. So this layer is between 0 and 10 kilometers, right? So this little triangle over here, this is the Everest mountain, 8 kilometers high. Well, this is nothing comparing to the rest of the atmosphere, but look, this is the mountain that we call the highest mountain in the planet. So, well, it depends altitude, taking water or something. So I'm gonna use this image. Obviously this is the Everest, but it's not to scale, it's only to show you, because it's tiny mountain here. So this is like a bigger version, okay? So this one is the Everest that it's represented right here to scale. And what happens when you go, let me talk about temperature to understand the troposphere. Remember, troposphere is the layer that has the air that we are breathing. It's the densest layer. It contains most 3/4 of the atmosphere is there. So all of the heaviest gases are there. And the temperature, what happens when you go to a mountain, I'm going to draw the effect of the temperature right here. We are going to start with 25 degrees. 25 is kind of like a warm conditions. So let's start right here. Temperature is also to scale. And when we are going up in a mountain, the temperature starts decreasing, right? It could reach even minus 15 Celsius, right? It could reach that it's super cold. Okay, so that is the effect that we have in the troposphere. When we are going up, because we have less air, less particles to heat, well, the temperature decreases. So that's the usual thing. Then we have a transition zone that is called the tropopause. The tropopause is not that thick, it's only between 10 and 12 kilometers. The tropopause is here and is this layer, and in that layer something interesting happens with the temperature. The temperature is not going up or down, it remains. It's kind of like it's stable. Oh, this is not the color that I was looking for. Okay, this one is the color that I was looking for. I'm going to use the green color because I'm talking about the tropopause. The tropopause temperature. So it establishes right there. So there in the tropopause, in that transition zone between the next layer, the troposphere, and the next layer, it remains like that. It stops moving, it stops increasing or decreasing. It remains. It established in that point. So in that area, in the tropopause, we have something interesting right here. This is the purple dot. Maybe you cannot see it, but this purple dot at 11 kilometers approximately in the tropopause is where the airplanes are. The aircrafts like Viva Aerobus here, it's using to travel. So that means that when you are traveling in an airplane, you can see the clouds below you, right? Some of the clouds, like cumulonimbus clouds, they are really they could be in a high altitude, but it depends on the weather, right? It depends. So yes, we have it right here at 11 kilometers. So let's move to the next layer, the stratosphere. The stratosphere is between 12, I think 12, that's why I have my notes, between 12 and 40 kilometers. Between 12 and 40 kilometers of altitude, we have the next layer. This one is thicker than the troposphere, is thicker. Do you see between 12 and 40? The stratosphere is very common. It has something very important. Well, strat means layer. So that means that it's kind of like a layered layer of the atmosphere. So it's kind of, well, the name, it's because one part of the stratosphere is kind of cold, but then it's kind of warm. It's kind of warm. So that's why it's called that way. And also because there we have a really important layer that is called the ozone layer. So sometimes you can see that the stratosphere is also called the ozonosphere because it contains the ozone gas. And that gas is the one that is absorbing all of the UV radiation from the sun, and because of that, something happens to the temperature. And I'm gonna just draw it with my red marker. So we reach minus 50 Celsius, right? Now the temperature is gonna increase. It's gonna increase a little bit until it reaches surrounding zero. Zero, when you are talking about 40 kilometers of altitude, it's kind of like, come on, zero is kind of warm, right? It's warm if you are talking about that altitude. So the ozone reacts with the sun and it warms up, the gas warms up because of the sun radiation. So it's kind of like a reaction from the sun that acts in the ozone gas that is there. That's why it's kind of warm. It's kind of warm, right? It's not as warm as here as 25 degrees, or it could be, come on, but we could reach 50 Celsius. That is kind of like hell, right? It's basically hell. So, but it's 0 Celsius is kind of warm, right? So the stratosphere has the ozone layer. So remember that one. The stratosphere means ozone layer protection. Let's move on to the next phase, the next transition zone that is called the stratopause. Do you see every single layer has its pause, and the pauses are transition zones. So the stratopause is the place where the temperature also remains the same. It doesn't change again, it doesn't decrease, it's not going to decrease or increase, it's just going to stay that way, stay that way, okay? So another transition zone, the stratopause, where the temperature remains. What else after the stratopause? After the stratopause, we have the mesosphere. Meso means middle. So this is the middle layer, right? This is the middle layer, and this one here, the temperature as well. Let me show you what happens with temperature. One more time, gets really cold. Below 100 Celsius, so it's kind of cold. It's really cold. Why is that? Because the mesosphere contains. Let me give you the number about the mesosphere. Is between 50 and 80 kilometers. 50 and 80 kilometers. So this layer, it's also called sometimes the ionosphere. And it's because, well, it's not the ionosphere, but the zodiosphere. Sodium, like sodium, the element, like zodiosphere. And why is that? Because there we have ice pellets, but instead of water, of being water, it's made of sodium. So we have sodium over there, ice, like ice. That's why it's really cold, because we have ice but made of sodium. Frozen sodium. That's why it's called zodiosphere as well. I have seen that name as well, not only mesosphere. So one good thing, and we have to say thanks to that layer, except the dinosaurs. The dinosaurs are not gonna say thanks to that layer because they weren't protected enough. Because here in this purple point, well, it's not a point, it's like a asterisco, I don't forget the name. So this one here is the burning up of the meteors. Meteors are burning up in that place because in that place, even that the air is super thin, it's enough to cause friction. And also because the difference of temperature, because the meteors can pass through the thermosphere, the exosphere, the thermopause, the thermosphere, and they are kind of fine. But the difference of temperature and the friction, because there is enough air to cause friction with the meteor, it's gonna burn up the meteor. So we have to say thanks to this layer that is burning up meteors for us. Not the dinosaurs, because that was a huge meteor, so it failed. So the last one. So the mesopause, also we have another transition zone right here, the mesopause. The mesopause as well, it has the same effect with the temperature, it has the same effect, it's gonna stay in that way, it's not gonna change anymore. And then we have something interesting. After just passing the mesopause, like at 100 kilometers of altitude, we have something that is really pretty right here at 100. Remember that this is not to scale, it's just to show you the tiny points right there. It's something that we call aurora, the northern lights, aurora borealis, that's the name. We have auroras not only in the North Pole, in the northern latitudes, also in the southern latitudes we have it, but in the south they are called auroras australis, because austral means south and boreal means north. So we have aurora australis and borealis, so we have both, and that is happening here at 100 kilometers of altitude, because there in the thermosphere, we get to the thermosphere that this is between 90 kilometers, well, I'm gonna put it over here, between 90 kilometers, God damn it, between 90 and 400 kilometers of altitude. So what is happening here in the thermosphere, that is sometimes known, this layer, as the ionosphere, is that the ionosphere basically has ions, right? Ions, and those ions are reacting with the sun rays and the sun wind. The particles from the sun, they are reacting, those ions, those particles are being charged. And the effect that we can see because of that reaction between the sun wind and the ions in that layer is the aurora borealis, that luminescent light. The thermosphere and the ionosphere are not exactly the same, because the ionosphere involves part of the exosphere, all the thermosphere, and also one part of the mesosphere. But this layer, the ionosphere, it's kind of different because it shrinks or expands depending on the absorption of the sun rays. So it depends. In that area, in the poles, you can see the aurora borealis, because in that area it's thick, it's thinner. So the sun rays come in, the sun rays, not the sun rays, the sun wind can enter to the layer in the atmosphere and react. In other places of the world, it's a thicker layer, so it cannot enter. So aurora borealis right here. What do you think happens with the thermosphere? Because thermo means heat, so that means that this layer, it's supposed to be heat, right? Well, yes, because of the name, we know that it's gonna be it's gonna be hot, this layer. So I'm gonna draw it for you, because it almost reaches, and I have seen different numbers, I have seen different temperatures in this layer. It reaches between 900, well, it's going from 0, it's to start with even below 0, 100 below 0, but it could reach even not only 900 or 800 Celsius, it could reach even 2000 Celsius. So it depends, it's really hot. But it's really strange what is happening here, because the air, the particles are really hot there. They are so scarce. They are super, they have a really big space between them. So even if you go there, maybe you cannot feel that. You cannot feel that temperature, because you are kind of small and the particles are really separated between each other. So maybe you are not gonna feel. So kind of like the temperature concept, it doesn't apply much when you are going or when you are reaching outer space, because there is no air to heat, there are no particles to heat. So it's kind of like a different concept right out there, right? But it's kind of like this is the temperature. So, but that doesn't mean that you are gonna burn there. Probably not, because remember, the particles are too separated from you, too scarce. It's like basically there's no air. And we have another transition. Oh, let me show you something more. Something more that is happening in the thermosphere is that the astronauts are living right there in the International Space Station. Almost at the end of the thermosphere, they are living right there in the International Space Station, and they live right there, and it's orbiting around us, surrounding the planet. I don't know how many times a day, but they are orbiting around surrounding us. And then we have the thermopause. We're almost finished. Well, basically, we're already finished. And another kind of like a transition zone where the air is getting thinner and thinner and thinner and thinner and thinner and thinner. And we have the shuttles, the space shuttles traveling there. This is the Discovery shuttle, and we have it right there in what we call the exosphere. So the thermopause is another transition zone where the temperature kind of like stays that way, but then we are going to have a drop of temperature, and we're going to reach even below zero. It's really cold, but like I said, it is kind of cold because there is no air, there is no particles to heat. So the concept really it doesn't apply the same way that here. So let's just refresh one more time. And well, exosphere would be between 500 kilometers and beyond. Why do I say beyond? Because yes, okay, it's between 500 kilometers. But I have seen different numbers as well with the exosphere. I have seen the exosphere, it's thicker as 10,000 kilometers. It goes to 10,000 kilometers, but also I have seen that it's kind of like to the middle of the distance between the moon and us. That would be in average like 200,000 kilometers. So kind of like it depends where you read, where you obtain the information. But I'm gonna use the NASA number. That is 10,000 kilometers, 10,000 kilometers. So that means that the exosphere, we have particles from Earth, kind of, but really like one particle is here and the other particle is super far away. So after this point, we could say that is outer space. So that means that the astronauts are kind of in our atmosphere. It's kind of close, and the space shuttles is not traveling that far. The satellites as well are living here. Well, are moving from in this area between the thermopause and the exosphere. It depends of the satellite, right? So troposphere, the layer where we live, where we breathe, where the 3/4 of the atmosphere is, of the gases in the atmosphere are, and then we have the stratosphere. I'm talking just about the layers, not the transition zones. A stratosphere where the ozone layer is protecting us from the UV radiation. The mesosphere, that it has the sodium particles, ice, and it protects us from the meteors. It burns up the meteors. Then we have the thermosphere, where you can see aurora borealis, and this is it's the thickest layer of all of them, and it reaches really high temperatures. And then we go to the exosphere, where we are in contact with the outer space. So it's important to see the layers to scale, because you can feel small and like you are nothing, right? To see the dimension, to get a different perspective of the altitude, right? So now you can do your own diagram, and you can also point special features of the planet to understand the dimension. If you have any question, remember to ask me.